Hello everybody, this video is going to cover our 4.5 notes, which are non-rigid transformations. These are also known as dilations. In the last set of notes, we talked about rigid transformations, which are transformations that do not change the size or the shape of your image. Today, we're going to be talking about non-rigid transformations, which doesn't really affect your shape. I guess it kind of does. But generally, when we talk about dilations, this is going to just change the size of your shape. Occasionally, it will change the shape itself, but I would say like 98% of the time, it's mainly going to affect the size and not the shape itself. Okay, so a dilation is a proportional, which means that your figures will probably be similar, a proportional enlargement or reduction of a figure through a point called the center of dilation. Oh, here we go. A figure and its dilated image are always similar, okay? So if the dilated image is larger than the original, then we have had an enlargement, and the scale factor is going to be something that is greater than 1. So you would see a scale factor like 5, or a scale factor of 3, or a scale factor of 1.5. Anything that's larger than 1 just means that your new image will be larger than your pre-image, okay? If your dilated image is smaller than the original, then it is a reduction, and the scale factor will be less than 1. So think 1/2, 2/3, something along those lines, okay? That's when your pre-image is larger than your new image. Something has shrunk, it has gotten smaller, it is a reduction. If it has gotten larger, then it is an enlargement, okay? So here we go. We're going to just jump right on into example 1. It says, draw a dilation of a quadrilateral ABCD with vertices at those places. Use a scale factor of 2. So because it's a scale factor of 2, that means that my new image should be larger than my pre-image. We're going to label the new quadrilateral LMNP. The dilation is centered at 0, 0. So it's important that we know where the center of dilation is, because 0, 0 means that we can do something really easy with the scale factor. If the center of dilation is elsewhere, then we're going to have to do something a little bit different. So you just got to pay attention, okay? So I'm going to label A at 2, 2. B is at 1, 2, 3, 4, 2. C is at 4, 0. And then D is at 0, -2. So we have this funky looking quadrilateral. And I need to apply my scale factor of 2. When your dilation is centered at the origin, then we're lucky that we can take our scale factor and multiply both the x and the y values of our original coordinates to both the x and the y values, and that will give us the new x and y values of our new shape. So our letters are going to correspond with each other because, again, our images are similar. So I know that A is going to correspond with L, B will correspond with M, C will correspond with N, and D will, oh, that's the wrong color. And D, where are you? D will correspond with P, but I'm just going to do them in the same color over here. Okay, so I get to take each one of my coordinates and multiply both the X and the Y by 2. And that's going to give me my new coordinates. So L will be located at 4, 4. M will be located at 8, 4. N will be located at 8, 0. And then P will be located at 0, -4. So I'm going to do this in orange. 1, 2, 3, 4, 1, 2, 3, 4. So here is L. M is at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's M. N is at 8, 0. And P is all the way down here at 0, -4. Oh, that's weird. Okay. Now, I'm going to go ahead and connect the dots. And hopefully that we see our new image is approximately 2 times as big as our original image. Okay. That's a really good way to check. If your new image was smaller than your original image, but your scale factor was 2, you should look at that and say, huh, that's weird. Okay. Now, one other thing that's really cool that doesn't really matter in geometry, but it will become more interesting to you when you get into the other classes, is the center of origin, or the center of dilation. So our dilation center is at 0, 0, which means that I should be able to draw a line from the center of my dilation, and it should hit all of the points on the same line. that did not sound good. Just watch what I do. That explanation was not stellar. So I am able to connect the two coordinates that go together, A and L, okay? When I draw my line all the way to M, notice that it goes through B because B and M are supposed to go together. When I draw my line from the center to P, it goes through D. Those go together. And then when I draw my line all the way over to N, notice that it goes through C. So that's how I can kind of tell where my center of dilation is. When you get into other math classes and you have to figure out where your center of dilation is, you kind of do that but go backwards. So I think that's really cool. I find that fascinating. You might not, but I think it's cool. All right, anyways, moving on. Coming over here to number 2, we are going to look at a triangle, and this time we are going to dilate it with a scale factor of 1/2, which means that my new image should be smaller than my pre-image, and the center of dilation is still at 0, 0. So here we go. 2, 1, 2, 3, 4. Here is A. B is at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Here is B. And then C is at 8. 1, 2, 3, 4. Down over here at -4. C. There we go. Okay. So I get to take each one of my coordinates and multiply them by 1/2 because my center of dilation is at the origin. So point D, I'll do these in green. How about that? Point D, which corresponds with A, will now be 1, 2. E, which corresponds to B, will be 4, 2. And then F, which corresponds with C, should be 4, -2. So we've got 1, 1, 2. Here's D. Here is E. And then F is at 4, -2. And there we go. Notice that my triangle is about half the size as my original. And then just for funsies, it's centered at the origin. Let's hit A. Look at that. Let's hit B. Look at that. Let's hit C. Look at that. My center of dilation is going through the points that correspond with each other. I think that's so fun. I'm a little bit of a nerd though, so there you go. Okay. Now, this one, I'm not going to graph it because I don't have to. It doesn't tell me to. It does, but I'm not going to graph it because I'm lazy. Okay, so it says we've got 2, 0, -4, -2, and -2, 4. I want to graph the image of A prime, B prime, C prime under a dilation at center 0 with center at 0, 0 and a scale factor of 3/2. So 3/2 is a scale factor that's going to be greater than 1. So that means that I should have an enlargement. But because my center of dilation is at the origin, all I have to do is take each one of my coordinates and multiply both the x and the y by 3/2. And I'm just going to do that. And then if you want to graph it, fine, but I'm not going to because I'm lazy. All right. So when I do that, 3/2 times 2 gets me 3, and then 0 times anything is just 0. -4 times 3/2 is -12/2, which is -6. And then -2 times 3/2 is -3. -2 times 3/2 is -6/2, which is -3. And then 4 times 3/2 is 12/2, which is 6. So if I were to plot those points on this graph, I'm going to do it. You know what? I'm just going to do it. 3, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3. And then -3, 1, 2, 3, 1, 2, 3, 4, 5, 6. That is my new triangle. My original one was at 2, 0, -4, -2, and then -2, 1, 2, 3, 4. So you can see that my new image is larger by just a little bit than my pre-image, which would make sense because 3/2 is just 1.5. So it's not getting bigger by much. It's getting bigger by a half. All right. So there we go. That is using scale factor to find your new image. What happens though, if I give you your new image and your pre-image together and we have to figure out what the scale factor is? Well, super easy, okay? When we are determining scale factor, we have to remember that our new image and our pre-image are proportional, right? They're similar, so our side lengths are going to be proportional to each other. So essentially what we have to do is figure out what the side lengths are, and I only have to figure out what one side length is of my new image and one side length of my pre-image, and just put the new image over the pre-image, and that will give me my scale factor. So super easy. Are you ready? You have a choice. I typically pick vertical because I think it's easier to count, but it doesn't really matter. But I'm going to pick the vertical, okay? So the side length of my original image, this is my original, and I know it's my original because it doesn't have any primes on it, is going to be 2. I'm going to do this in pink so you can see it. 2. My new image has a side length of 1, 2, 3, 4, 5, 6. Okay, so to find your scale factor, you have to do new over old, or original, whatever you want to say, new over old. So my new side length was 6. My original side length was 2. When I simplify that, I get 3. So my scale factor was 3. And you should go back and say, okay, was my pre-image smaller than my new image, or was my new image bigger than my pre-image, whatever you want, whichever way you want to go. Because my new image was bigger than my pre-image, I should have a scale factor greater than 1. I got 3. If I had flipped it and done original over new, I would have gotten 1/3, and I should look at that and say, oh, that's not right. I can't have a scale factor of 1/3. My new shape would be smaller than my original shape. Okay, so that's how we do it. You have a choice. You can either use the horizontal length or the vertical length, but you have to pick one. Okay, what's going to happen if we have a shape like this, though? It's a triangle, but we don't have a nice vertical or horizontal length. It doesn't matter. We can make one. So what I'm going to do is I'm going to figure out the distance vertically from A to B. Okay, that is 1, 2, 3, 4. Okay, so vertically the distance from A to B is 4. So then vertically I have to find the distance from A prime to B prime, and that is 2. Okay, just vertical distance, 4 and 2. So I need to do my new image. Oh, good Lord. New image over my old or original image, okay? My new image this time is has a side length of 2, and my original had a side length of 4. So when I simplify that, I actually get a 1/2 scale factor, which makes sense because my image got smaller, not bigger, okay? If I did horizontal, you can kind of go whatever way you want. I could have gone horizontally from B to C. 1, 2, 3, 4, 5, 6. 1, 2, 3. And again, I would do 3 over 6, which is 1/2. So it doesn't matter what you choose. But I am a big believer in picking something and sticking with it. That way you're not trying to change your methods a bunch of times. And you'll have more consistency and less likely to make a mistake. Okay, let's move down to example 6, where they give me really big numbers. Disgusting. Okay, I'm going to plot A, B, and C on my graph. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. I wanted that to be in the color black. That's A. B is -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is it all the way down here? And then C is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Here is C. So here is my triangle. Okay, now I know that A prime is at 1, 1. So here's my A prime. And then B prime is at -2. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, B prime. So here's what I have. Okay, notice that your new image is going to be significantly larger than your pre-image. Okay, I have to figure out what the scale factor of the dilation is, and I need to find C prime. Now, here's the problem with this one, okay? I don't know where my dilation happened at. It could have been at the center. It could have been somewhere else, okay? So what I'm going to have to do is kind of ignore the center of dilation for a minute, and instead I have to figure out what the scale factor is. So no matter what, your first goal is to figure out scale factor. So I'm going to find the distance from A to B vertically, and then again, the distance from A prime to B prime vertically. So here we go. 1, 2, 3. So I've got a vertical distance of 3. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, so to find your scale factor, you're going to do new over original, which for us is going to be 9 over 3, which means that I have a scale factor of 3. That is important. Okay, now that I know what my scale factor is, in order for me to find C prime, I have to find the distance from either A to C or B to C, both horizontally and vertically. Once I find the distance, I then have to multiply the distance by the scale factor. So I just need you to stick with me. We're going to do examples of this. I'm going to explain it again. Watch what I do. Ask questions to your teacher if you need more help. I'm going to find the distance from B to C, okay? I'm going to do this in green, so it's a different color. 1, 2, 3, 4. So this is a distance of 4. This is a distance of 1. In order for me to find C prime, I have to take those distances, that 4 and that 1, and I have to multiply those by the scale factor of 3 to get the new distances. So I know horizontally, I'm going to take that 4, I'm going to multiply it by 3, and I now know that my new horizontal distance should be 12. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Then horizontally, my distance was 1. I have to multiply that by 3. So now I know that my new distance will be 3 horizontally. 1, 2, 3. Okay? That is where my C prime should go. Connect your dots. Double check your shapes. That looks pretty darn tootin' good to me. So let's figure out where C prime is. Oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So it's 10, negative 5. Okay, we're going to do it again. We're going to do it again. First thing you should always do, find your scale factor, because without your scale factor, you can't really do anything else. Okay, so I'm going to find the distance vertically from A to B, and then A prime to B prime. 5, 6, 1, 2, 3. Okay, so here we go. God, why do I keep doing that? New over old. Okay, my new is 3. My old is 6. So I have a scale factor of 1/2. I need that, okay? All right, I'm going to find the distance both horizontally and vertically from B to C. I got to take both of those distances, multiply by 1/2 to get the new distance of C prime. Here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so horizontally, I want some space. Horizontally, I'm going to take my distance of 6, multiply that by my scale factor of 1/2, and I get a 3. So horizontally, I'm only going to move 3. Vertically, I had a distance of 4. I multiply that by 1/2, and I get a new distance of 2. Here we go. Horizontally, 1, 2, 3. Vertically, 1, 2. That right there is my new C prime. When you look at your graph, those two triangles should look identical. One is just bigger than the other, or one is smaller than the other, okay? So C prime will be located at, whatever. Okay, so C prime will be located at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7, 5. And there you go. That's the hardest part of this. If you can do that, everything else is easy breezy, beautiful cover girl. All right, last. Dilations affect the whole shape, resulting in similar figures as we saw on the previous example. So everything that we just saw, the only thing that was changed was the size, right? It didn't, like the shape didn't change. The triangle was still the exact same triangle. It was just bigger or smaller. You can also have changes that affect only the horizontal X or the vertical Y values of a shape. Okay, these stretches and compressions come from multiplying only the X or Y values of the ordered pairs that represent the vertices of a shape. So, you know, up here, specifically these first 3 examples, okay, we were multiplying everything, both horizontal and vertical, by whatever the scale factor was, okay? So it didn't change the shape, it just changed the size. What we're going to be doing now, what we're going to be doing now is instead of multiplying the X and the Y by the same value, we're going to be multiplying them by different values, okay? So anytime that you are doing something horizontally, left to right, that affects your X values, and then vertically is going to affect your Y values, all right? So we are given 3 coordinates. I'm going to go ahead and graph those first. negative 2. Negative 2, negative 2 is A. B is at 1, 2, 3, 1, 2, 3, 4. And then C is at negative 5. Oh, God. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Here is C. Here is my beautiful triangle. And then I am supposed to be horizontally, so that affects your x's, horizontally stretch the triangle by a factor of 2. So horizontally, I am going to multiply my x's by a factor of 2. And then vertically compress by a factor of 1/2. So that is going to affect my y values. And then we're going to get a new coordinate. I'm going to do this in purple. So my triangle should get longer horizontally, but then shorter vertically. So I'm going to get a shorter, wider triangle, essentially. Okay. So this will get me negative 4, comma, negative 1. This will get me 6, comma, 2. And this will get me negative 10, comma, 4. So let's graph that. 1, 2, 3, 4, 1. That's A prime. 1, 2, 3, 4, 5, 6, 1, 2. There's my B prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. And there's my C prime. So did my triangle get wider horizontally? Yes, it did. Did it get shorter vertically? Yes, it did. Now, here's the thing. When you do this, you no longer have similar figures, okay? Similarity does not affect the shape, and it definitely doesn't affect the angles, and the angles are most definitely affected right now, okay? So just FYI, if you watch this video, this is an example of something that you may or may not see on your midterm, so keep that in mind. Anyways, that is all I have for you today on these notes. If you have any other questions, please go see your teacher during their normally scheduled tutorial times. And I will see you in the next video. Bye-bye.